In this lecture, we'll be discussing about logical versus physical address spaces. So we are going to discuss about two types of addresses, which is a logical address and the physical address. And we'll also see what is logical address space and what is physical address space, how do they differ, and if they differ, how can they be related or how can we map one to another. All right, so first of all, let us see what is a logical address. So logical address is an address generated by the CPU. So the address generated by the CPU is what we mean by logical address. And what is a physical address? An address seen by the memory unit, that is the one loaded into the memory address register of the memory. So this is what we mean by physical address. It is an address that is seen by the memory unit. And what do we mean by seen by the memory unit? That means that is a particular address that is loaded into the memory address register of the memory. So just keep in mind that logical address is the address that is generated by the CPU, and the address that is seen by the memory unit or the address present in the memory address register of the memory is known as the physical address. Now, compile time and load time address binding methods generate identical logical and physical addresses. So in the previous lecture, we have studied about address binding and we saw different kinds of address binding. We have discussed about compile time address binding, load time address binding, and execution time address binding. Now the first two, that is the compile time and the load time address binding, if we are using these methods, they generate identical logical and physical addresses. That means in compile time and load time address binding methods, the logical address, that is the address generated by the CPU, and the physical address, that is the address seen by the memory unit, they are the same. It is identical. Okay. Now in case of execution time address binding scheme, it results in differing logical and physical addresses. But in case of the execution time address binding, the logical address and the physical address that is generated, it differs from each other. They are not the same. So in this case, we usually refer to the logical address as a virtual address. So if we are talking about execution time address binding, since the logical and the physical addresses are different, we will refer to logical address as a virtual address. So when we say virtual address, just know that we are talking about logical addresses. So now we understood what is the meaning of logical address, what is the meaning of physical address, and we saw how logical addresses and physical addresses vary in different address binding methods. All right, now let us see what is logical address space and what is physical address space. Now logical address space, it is a set of all logical addresses generated by the program. So from the name itself, it is very easy since we already understood what are logical addresses. So logical address space is the set of the logical addresses generated by a program. So for a particular program, the starting logical address to the ending logical address for that particular program, that will be the logical address space for that particular program. And similarly, physical address space is the set of all physical addresses corresponding to these logical addresses. So the physical address space will be the set of all physical addresses that corresponds to these logical address spaces. So when we say corresponding to these logical addresses, keep in mind that if we are talking about compile time or load time address binding, the address spaces will be the same because the logical addresses and the physical addresses generated during compile time address binding and load time address binding are the same. But in case of execution time address binding, the logical address space and the physical address space will be differing. So in execution time address binding scheme, the logical and the physical address spaces, they differ. They are not the same. So if they are not the same, how will we map them to each other? How will we know that for a particular logical address space, this is the corresponding physical address space? So how are we going to map them? So this is the problem that we have and the solution that we need to find. So how can we solve it? We can solve it using this. The runtime mapping from virtual to physical addresses is done by a hardware device called the memory management unit or the MMU. So during runtime, we need to map the virtual address to the physical address. So as I already told you, when I say virtual address, remember that I'm talking about the logical address. So these virtual addresses has to be mapped to the physical addresses during runtime, and for that we are going to make use of a device called the memory management unit, which is a hardware device. So let us see how does this memory management unit work. So here we are going to take an example of dynamic relocation using a relocation register. Okay, so here we have the CPU and here we have the MMU, which is a memory management unit, and here we have the memory. So the CPU generates a logical address. So let's say 238 is a logical address generated by the CPU. And this relocation register here, it will contain the starting physical address for the memory location for our particular program. So when we have discussed about the basic hardware, we have discussed about the base register and the limit register. So base register was something that stores the starting address of the address space of a particular process. So this relocation register is something similar to that. It will contain the starting physical address. Now, whenever a logic address is generated, we need to convert it to the corresponding physical address. So what we will do is we are going to add the logical address to the address that is present in the relocation register. So here we have 15000. So the logical address is 238. So if we add them, we get 15238, which will be the corresponding physical address for this logical address. So the logical addresses, they will range from 0 up to the max value of whatever the logical address is. And the relocation register will contain the starting physical address value. And then we can get the corresponding physical address by adding the logical address to this address present in the relocation register. So for the CPU or for the user program, they think that the addresses are from 0 up to whatever is the maximum value in the logical address space. So let's say that, for example, for a particular process, the logical address space is from 0 to 300. So according to that user process, it only sees that 0 to 300. It does not have to worry about what is the corresponding physical address. Why? Because this memory management unit is going to take care of that. So the user process is only going to see from 0 to 300, and whatever it is trying to access will be added to this value here and will be converted to the corresponding physical address. So for example, if it is trying to access the first memory location, so what will be the value? It will be 0 because it starts from 0 to the maximum value as we said in our example. So if it is 0, what will be the corresponding physical address? It will be 0 plus 15000. So it will be equal to 15000. So 15000 is the starting physical address for that particular process. So this is how we can make use of the memory management unit by this simple example of dynamic relocation using a relocation register to find the corresponding physical address for a logical address. So now we have two type of addresses, the logical address in the range of 0 to max, which I just explained now, and the physical address in the range of r plus 0 to r plus max for a base value r. So what is r? R was the value that was present in our relocation register. So in our example, it was 15000. So the physical address range is from that 15000 plus 0, and this 0 corresponds to this logical address. So r plus 0 to r plus max. So that is the physical address space that we have. So the user generates only the logical addresses and thinks that the process runs in locations 0 to max. So this is what is perceived by the user because the user only sees the logical address space. The user thinks that it is only from 0 to max. But what happens inside, the memory management unit takes care of it and it is converted to r plus 0 to r plus max, and that is the corresponding physical address. But the user does not have to worry about it. The user program supplies a logical address and these logical addresses must be mapped to the physical address before they are used. And this is done by the memory management unit. So this is how logical addresses are converted to physical addresses. So we studied about logical addresses, physical addresses. We also studied about logical address space and physical address space, and we saw how these addresses are mapped to each other and how logical addresses are converted to physical addresses. So I hope this topic was clear to you. Thank you for watching and see you in the next one.